Ladies and gentlemen, could the seed oils be the primary cause of the diseases of civilization? Heart disease, hypertension, stroke, cancers, type 2 diabetes, metabolic syndrome, obesity, Alzheimer's disease, macular degeneration, the list goes on and on. And could these so-called heart-healthy vegetable oils actually and ironically be the primary cause of heart disease and the major cause of all these other diseases of civilization as well? Take a look at this front page of an article from Harvard, if you would. Now, dare I have the audacity to question the Harvard School of Public Health? And the nutrition department of Tufts University? And the nutrition department of Mayo Clinic? And the American Heart Association? Yet that is exactly what I will do today, and this is exactly the hypothesis that I will present and defend today because I believe in it. So why would I think this? Paracelsus' dictum states that the dose makes the poison, and we're consuming these highly pro-oxidative, pro-inflammatory, toxic seed oils in massive doses, and consumption has spread all around the world, and the entire world is becoming overweight, obese, and sick. And it's not their fault. My charge to you today is that while processed foods are driving virtually all of this chronic disease, of the processed food components, and there's basically only 4, it is the seed oils that are the primary drivers because they are the biological poisons. They are poisons, plain and simple, and today I'll try to show you how and why. So, my financial disclosures first. I'm a book author, I'm a researcher, and I'm the founder and president of Cure AMD Foundation. I accept no compensation for any of these roles, so I apparently have no financial interests. That's not really true though, because we still like to eat. So, anyway, all right. What I will submit to you is that there are really 2 primary drivers of obesity and chronic disease. Yes, obesity and chronic disease, and it's nutrient deficiency and toxicity. But there's only a single source for this, and it's processed foods. So, I know this is not news to you, but this is so fundamentally and critically important, I believe. And if you think about this, if you flip this on its head, processed foods are the sole driver of nutrient deficiency and toxicity. And we're not paying nearly enough attention, I don't believe, to nutrient deficiency or toxicity, either one. Now, if you look at processed food as a percentage of the American diet, all this in the red, you can see, as of 2009, 63 to 74% of the American diet is made up of processed food, and processed food is just 4 things: vegetable oil, trans fats, sugar, and refined wheat flour, right? All right, and if you add in alcohol, that adds another 70%. So what this means is none of that has virtually any micronutrients, right? You don't get vitamins out of that, and it's really mineral deficient as well. So that means you've got 29% of your diet left to give you all of your nutrients, right? And we haven't even gotten into the toxicity of the processed foods, and you're gonna have a lot of toxicity with polyunsaturated vegetable oils, trans fats, and at least the fructose component of sugar. All right, now, I went to medical school 1986 to 1990, and I'm gonna give you more history about medicine in the next 4 or 5 minutes than what I got in 4 years of medical school, I promise you. All right? So, because I think this is critically important, and when we look at this and then we correlate it to the diet, it's powerful. Okay, so here's what we usually see, right? The world is getting heavier, United States leads the way, all right? We're winning this race. And here's where the US dietary guidelines were introduced, 1980. All right? And we know total energy intake over the next decade went up about 250 calories a day, right? Everybody's probably seen this. And then the next thing that often is said is, as you can see, carbs went up, fat went down, carbs are the problem, right? Not so fast. The fat composition here is still changing, and that is going to be the crux of what I'll try to show you today. Now, this is Jones' paper from 2011, and what it shows is that in 1900, the top 3 causes of death were all infectious disease. It was pneumonia, tuberculosis, GI infections, right? Whereas by 2010, 7 of the top 10 causes of disease are all chronic disease. Heart disease, cancer, stroke, Alzheimer's disease, type 2 diabetes, all that, right? So, let's walk through heart disease over the last 200 years. So from Jones' paper, we know that in Boston, in the town of Boston, in 1811, there were no heart disease deaths listed. All right? There was 25 sudden deaths. Probably most of those were cardiac valvular. All right? In the entire 19th century, there's 8 worldwide papers, reports essentially, of heart disease, extraordinarily rare disorder. 1897, Sir William Osler, famed physician of Johns Hopkins, he recounts his previous 21 years of hospital history, about 6 cases of angina, never seen an MI, never seen a heart attack. 1900, Jones' paper tells us 12.5% of people died of heart-related disease, but it was virtually all cardiac valvular. It was syphilis, endocarditis, rheumatic fever. Well, it wasn't coronary artery disease related, right? 1912, John Harry publishes the first known case of heart attack in the United States, documented with autopsy evidence. 1930s, though, heart disease becomes the leading cause of death. Virtually unknown 30 years earlier, all right? In fact, when John Herrick published the paper about the MI, it wasn't even taken seriously for about a decade, all right? Advance forward to 2010, 32% of Americans dying of heart disease, virtually 1 in 3, all right? So the increase looks something like that red line right there. Cancer, Boston, 1811, 1 in 188 people died of cancer. 1900, it's rising, 1 in 17 in the US. 2010, 31.1% of people die of cancer, right? That's almost, again, 1 in 3. So the increase looks something like this. And what I hear all the time is, yeah, but we're getting older. I'm telling you that does not explain this. And let me tell you very quickly, and I've written on this, I've spoken on this. Let me give you two quick statistics. In the year 1800, 43.3% of children did not live to see their 5th birthday. In 1900, it wasn't much better. 36.2% of children did not live to see their 5th birthday, and 4% of women died in childbirth. That drops the life expectancy down drastically, and that's why that's so low. So back to cancer here, 62-fold increase in cancer in 200 years, right? How about type 2 diabetes? We know in the 19th century, diabetes of any type was rare and presumably rare for all of history prior. 1935, it's rising, 0.37%. This continues to rise. And we're at 9.4% by 2015. This is a 25-fold increase in type 2 diabetes in 80 years. How about obesity? 19th century. We know that obesity was 1.2% in men, age 18 to 80, in Texas and Nebraska prisons, right? Okay, look at this. By 1960, we're at 13% obesity. That was a 10-fold increase already, right, when we thought we were lean. So this continues to rise, and by 2015, we're at 39.8% obesity, right? This is a 33-fold increase in obesity in about 115 years, and we are on target to be at 50% of Americans obese by 2030. That was published in JAMA just a few weeks ago. Okay, age-related macular degeneration, my area of expertise. 1851 was when this disease was first discoverable. Between 1851 and 1930, there was no more than 50 cases of macular degeneration, which is the leading cause of irreversible vision loss and blindness in people over the age of 65. No more than 50 cases in all the world's literature. Yet, today, this year, 2020, 196 million people affected worldwide, on target to be 288 million by 2040. So what this means, back in the 19th century, 1 in many thousands of people affected. And I'm telling you, they were looking. I've read all the textbooks. Today, again, almost 1 in 3, 29% affected since 1990. Okay, there's the increase, essentially. All right, now we're going to hit 200 years of dietary history, which is really a global human experiment, is the way I look at this, without informed consent, right? Because nobody chose this. Sugar. 1822 to 1999, sugar went up 17-fold. We know sugar is a nutrient-deficient diet, nutrient-deficient food, right? Next, and the most important thing of all, cottonseed oil introduced right after the American Civil War, about 1866, 1867 is when we first began to consume this, and this is where the human experiment really began, all right? And you'll see why. 1880, we get roller mill technology, which gives us refined white wheat flour. Now, wheat is 20% of the world's diet. At least in the United States, 85% of that is refined, so it's nutrient deficient. 1911, Procter & Gamble gives us Crisco, trans fats. Right? There we go. That's processed food. That's it. That's all of it right there. We had all the processed foods in place, essentially, by 1911. And then they just took off. So today in the United States, 600,000 foods available, and the bulk of them are made right out of that. Now, 1939 and 1945, Weston Price connected all of this together and made us all aware that Western diseases were driven by people consuming these foods, but nobody listened. And then if you look at this, the far right slide there, from our own USDA, they recognize this. Those 4 foods make up 63% of the American diet, right? They know this is the problem. So diseases of civilization, the docs right there, look something like that. Okay, let's go back to 1918 for a minute. This is Elmer V. McCollum, nutritional researcher. This is a book he wrote, The Newer Knowledge of Nutrition, and this is extraordinary. It covers thousands of animal studies because they really wanted to know what was going on with diet. They wanted to understand what it was that was driving health. And I'm going to give you an example here. And there's extraordinary studies. This is just one of many. All right, so they take diets. Now these rats are usually weaned at about 25, 26 days. And then they put these two sets of rats on identical diets except for one thing, the fat source. All right, so the rats on the left get 5% cottonseed oil. The rats on the right, 1.5% butterfat. That's all the fat they got, 1.5%. Here's what happens to them. The rats on the cottonseed oil grow to 60% of normal size and live 555 days on average. They're weak, fragile, sickly little rats. The rats on the butterfat, they are healthy, they grow to normal size, and they live 1,020 days. So they grow to almost twice the size, live twice as long, and are infinitely more healthy. Why? Anybody? Why? Fat-soluble vitamins, A, D, and K2, right? Those are not in any kind of vegetable oil. Any kind of oil at all, in fact, that comes from plants. You're going to see this next. So McCollum says this in 1918. 1918, just look at the part I have underlined here. The diet must contain 2 as yet unidentified substances or groups of substances. One was fat-soluble vitamins, the other water-soluble. He says, one of these is associated with certain fats and is especially abundant in butterfat, egg yolk fats, and the fats of the glandular organs such as the liver and kidney. That's all the fantastically healthy foods, right? Right there. He says, but is not found in any fats or oils of vegetable origin. Even the healthy oils, coconut, palm kernel, avocado oil, real true olive oil, they don't have vitamins A, D, and K2, right? They're not there. He continues, McCollum, 1918, he says, both the growth-promoting fat, which is butter, and the trace of unidentified substance in the alcoholic extract of wheat germ, which was the B vitamins, are necessary for the promotion of growth or the preservation of health. We don't just need these vitamins to grow, people. We need them in adulthood and old age in order to sustain us in good health. And this is what we continually overlook, especially when we focus on macronutrients, I believe. Okay, so let's get on the same page here, because vegetable oils have a lot of names these days, right? But vegetable oils, seed oils, also known as polyunsaturated vegetable oils, PUFA or polyunsaturated fatty acids, edible oils, now the newest euphemism, plant oils, I think, meant to just confuse us, omega-6 oils, and then linoleic acid. Now, linoleic acid, if you don't know, is the 18-carbon omega-6 fat that is sort of exemplary. It's the primary fatty acid of these vegetable oils. All right, it accounts for about 80% of the fatty acids. All right, now here's the dreadful ones. All right, the high PUFA oils: soybean, corn, canola, cottonseed, grapeseed, sunflower, safflower, and rice bran. There, I've said it. If I've said it once, I've said it a million times. These are the ones that are particularly dangerous. I'm sorry I don't have time. We have to move pretty quickly. All right, so this is from our paper recently, and this is vegetable oil consumption in the United States for essentially all of history. Notice, 1866 to about 1909, we're like 2 grams a day. And then it just takes off as we start getting soybean oil and all these other oils, right? And so by 2010, we're at 80 grams a day. Okay, so we went from 0 in 1865 for all the world and for essentially all of history, pretty much, to 80 grams a day. Now let me just say, this is an infinite increase in vegetable oil consumption. A lot of people talk about Tanya Blasberg's research where soybean oil went up 1,000-fold between 1909 to 1999, which indeed it did. But all this vegetable oil is an infinite increase. 80 grams a day, folks, is 720 calories worth. That's 32% of US caloric intake. A third of our diet is coming out of factories that make these oils. I can't tell you how dangerous this is. So 1900, 99% of our fats came from animal fat, lard, butter, beef tallow, and suet, essentially. But by 2005, 86% of added fats came from vegetable oils. And notice, the vegetable oils are still going up, right? Now, take a look at this. Here's where the dietary guidelines were introduced, right? 1980. And remember, our fat consumption was going down and our carb consumption is going up. So guess what? Our animal fat consumption is still trending down and our vegetable oil consumption still going up. Didn't just happen in the US. Here's developed countries, doubled in a period between 1963 and 2003. This is all around the world. Developed countries doubled. Developing countries tripled. Japan, for example, 4.5-fold. China, almost an 8-fold increase. And this ended 17 years ago, this data. Where are we today? The Asians are getting as sick as we are, right? Okay, so here's the dietary fats essentially that are added to our diet, right? Coconut oil, butter, palm, and lard. So the top 4, see all the red? That's all the saturated fat. That's what's healthy. Now, from cottonseed oil down, all that blue, that's all these vegetable oils. And all that blue is the omega-6 linoleic acid, just that. That's what that is right there. If you transplant yourself back to 1865 and for all of history and for all the world essentially, this is where all the fats came from. Butter, lard, and beef tallow at 3, 2, and 2% omega-6 fat. So in other words, here's where we are today, all that blue, all that omega-6. Here's where we were in 1865. So what did this do to us? 1865, I calculated this. This is what our omega-6 consumption would have been in 1865 with 40% animal fat from traditionally raised animals, 2.2 grams per day, less than 1% of our calories. And then you can see this is increasing. By 1909, we're about 2% of our calories. 1999, we're at 7% of calories and 18 grams a day. And 2008, 11.8% of our calories and 29 grams a day. We went from 2.2 grams to 29 grams a day. You're going to see why this is so important, because we can't burn these for fuel properly. They're meant to be stored and used as signaling and structural molecules, particularly in the mitochondria, and they're not meant to be burned as fuel. So that's why we accumulate these. This, I want to make notice here, that's 2.2 grams is not yet published data. That will be in our next scientific paper. But this is a 12-fold increase in omega-6 in about 145 years, 12-fold. Okay, what did it do to us? Here's heart disease. And this is our published data as well. Look at the vegetable oil in black versus the heart disease deaths in red. Right? Everybody see a remarkable correlation? How about saturated fat in the purple versus heart disease? Anybody see any correlation there at all? Saturated fat practically flat for the whole last century, changed 5 grams, right? In fact, I would submit, if you see a correlation between saturated fat here and heart disease, you would also believe that Arnold Schwarzenegger and Danny DeVito are indeed twins. Okay, so there's a bunch of populations around the world that we know don't have heart disease, right? And I'm not even going to name all these, but they all have very similar things in common. So let's talk about 3 of them very quickly. The Maasai tribe of Kenya and Tanzania. Now, just so you know, this is where Kenya and Tanzania are in Eastern Africa, and I'm just going to say, this is what all these Maasai warriors, all the Maasai look like this. Lean, healthy, chiseled, fantastically healthy people, right? Well, anyway, George Mann and colleagues in around 1970, 1972, extensively studied them. Now, what do the Maasai eat? Milk, meat, and blood from the cattle they herd. They're pastoralists. The typical warrior drinks 3 to 5 quarts of raw, whole milk per day, and their milk has a lot of saturated fat. 3,000 calories a day. These guys only weigh about 128 pounds on average a piece. Their diet is 66% animal fat, 33 to 45% of that is saturated animal fat. It's about 17% carb, 1.7% omega-6 fat. Now that's the number I want you to pay attention to this whole time if you would. All right, well, what did George Mann find? They did 50 autopsies and they did, I think it was 350 EKGs, no heart disease, no heart attacks, except 1 possible silent MI in the entire group. Yet, our American Heart Association says no more than 5 to 6% saturated fat, right? So how do these guys get away with consuming up to 45% saturated fat? Well, American Heart Association would just say it's another paradox, right? Conventional medicine would say this: fools, don't you know animal fat would kill you? Right? They would say this: you must eat more healthy polyunsaturated oils like Americans. So this is an animal fat diet. This is polyunsaturated fat diet. Animal fat, polyunsaturated fat. How many times should I do this? Okay, let's move down to Tokelau in the South Pacific, kind of midway between Hawaii and Australia. 3 little islands down there, atolls. The Tokelauans were studied 1960s, 70s, and 80s. Very interesting, because here's their diet: coconut, fish, starchy tubers, and fruit. That's it. It's very simple. 54 to 62% of their calories come from coconut. Coconut oil, 91 to 94.5% saturated. Their diet was 53% fat, high-fat diet, 48% saturated. So while the Maasai hold the honors for the most saturated animal fat in the world at up to 45%, the Tokelauans have the most saturated tropical oil fat in the world at 48%. Guess what? 2% of their diet is PUFA. Now that's total PUFA. That's omega-6 and omega-3 together. Well, so where are they getting their PUFA? From fish and coconut. That means that about half of that was omega-3. So their omega-6 PUFA is about 1%. Again, that's the number I want you to pay attention to, if you would. 1982, they studied men 40 to 69 years of age. No heart attacks. Virtually no obesity, no diabetes in this population. They are fantastically healthy. Okay. Now, this will look like a diversion, but it's not. This is the omega-6 linoleic acid in our adipose tissue in Americans, 1959 to 2008. Stephen Guinea collated 37 studies where they had biopsied the fat of Americans. Now look where our omega-6 linoleic acid was on average in 1959, 9.1%. Okay, this is in our fat. And do you know what our obesity was in 1959, 1960? 13%. Okay. In 2008, our linoleic acid in our fat, 21.5%. And you remember I showed you that in 2008, our omega-6 in our diet was 11.8%. In other words, it approximately doubles in your fat because we accumulate these. And they accumulate in your cells and in your mitochondria. And this is where they wreak havoc because it's polyunsaturated. And they're the ones that oxidize. All right, so 2008, you know what our obesity was? 34%. Now, the next thing I'm going to show you, I searched for 3 years to find this. You know what I wanted to know? What was the omega-6 fat in anybody's adipose who was on an ancestral diet? Anybody in the world. I finally found it. Tocolalins. Right here. 3.8%. It is off the chart low. Remember I said their omega-6 in their diet was roughly 1%? 3.8%, people. This is where we should be. And this is what keeps you healthy. Right here. Okay, one more population. Tukasinta, Papua New Guinea. The Papua New Guineans in this study were evaluated extensively. 1966 to 68. Sweet potatoes account for more than 90% of their calories. They live off of over 1,000 different kinds of sweet potatoes. This is one of their harvests. They occasionally feast on pork and chicken. They are pork herders, but would rarely eat their pork. So here's their diet, 1966 to 68. 94.6% carb, 3% protein, 2.4% fat. Omega-6, there's that number again, 0.6%. Now, what'd they find about them? Here's what they say in the studies. Population was lean, physically fit, and in good nutritional state. Absence of obesity and hypertension. No diabetes or gout was found. Ischemic heart disease was rare if not absent. And no macular degeneration. 340 people over age 40, none. Now, absence of obesity. If we think that carbs drive insulin and insulin drives fat, how do we explain this? Okay, I'm just going to move on. Now, here, what do these healthy populations not have? No sugar, no refined wheat, no processed foods, and no vegetable oils, of course, right? All right, so let's talk about their macronutrient ratios. Did the carb percent matter in these populations? Assuming you're consuming an ancestral diet, did it matter? No. It was 17% in the Maasai, about 95% in Tukasinta. How about the fat percent? Did it matter? Also, no. About 2.4% total fat in Tukasinta, 66% animal fat in Maasai. How about the fat composition? Did saturated fat seem to matter in any of this? Doesn't matter. About 1% Tukasinta, 45% in the Maasai, 48% in Tokelau. How about monounsaturated fat? Also doesn't matter. About 1% in Tukasinta, 53 to 65% in the Maasai. All of them fantastically lean, healthy, and without heart disease. Now the big question. What about the omega-6 PUFA? Right? This is the elephant in the room. I know people talk about this, but what should it be? 0.6 to 1.7%. I couldn't make the font any bigger than that. I tried. It's big, 93 or whatever it is, as big as it'll go. Okay, now compare this to westernized populations. The omega-6, 7 to 12% today in our diets. Remember, we were at 7% in 1999. Now we're at 12, or we were at 12% by 2008, 11.8%. Now I don't know where we are. I mean, we're higher than that. Okay, so let me explain what I think is going on here. Remember I said the problem is pro-oxidative and then toxic, right? Here's the pro-oxidative part. So when you consume omega-6 to excess, which is going to be a westernized diet, it'll have nutrient deficiencies, but what matters is it combines with reactive oxygen species like hydroxyl radicals, which we produce 1 × 10 to the 10th per day in every person. Okay, so this begins a catastrophic lipid peroxidation cascade. These polyunsaturated fats accumulate in your cells, accumulate in your membranes, accumulate in your mitochondria, and they cause a peroxidation reaction. But this devastates cardiolipin, and this leads to electron transport chain and oxidative phosphorylation failure. Electron transport chain is where we create 90% of our energy. So when this happens, we have mitochondrial dysfunction. So we lose energy production. And this is why every single one of these disorders, you know, from heart disease to atherosclerosis to type 2 diabetes to macular degeneration and cancer, all have the same thing. They all have mitochondrial dysfunction. This is why. Now, the very first thing that happens when the electron transport chain fails in this scenario is that it starts shooting out reactive oxygen species. These are hydroxyl radicals and superoxide, and this took me years to understand, to try to understand this. And so that creates a catastrophic lipid or feeds back to the lipid peroxidation. Then the next thing that happens is insulin resistance at the cellular level. Because this is what's happening. The cell, there's so much reactive oxygen species and the electron transport chain is failing, and the cell gets sick. And it puts up its stop signs and it says, look, I don't want glucose, I don't want fatty acids, I don't want anything. I'm sick in bed. I can't do this, I can't work, right? So now I'm insulin resistant. And so, you know, that ends up leading to metabolic syndrome, type 2 diabetes, and so forth. But what I will submit to you is it's not that we're consuming carbs and you start filling up the cell and all that. I will submit to you, even if we can't measure it, the very first thing that's happening in this scenario is the insulin resistance comes first. Then you start developing lipid droplets and so forth in your cells, in your liver, and so forth. Okay. What's next? Reduced fatty acid beta oxidation, because the electron transport chain is not working well. So now you're not burning fat for fuel properly. So the person gaining weight and getting sick in this regard is now carb dependent. Their glycolysis is working, but their Krebs cycle and electron transport chain aren't working to burn fat for fuel properly. All right, so now they start storing the fat, right? So this leads to obesity. Now, loss of energy leads directly to nuclear and mitochondrial DNA mutations. And what do we get out of that? Cancers. Next, heart failure. You're going to see this in just a minute. In just a few minutes, I'll go through this. Mitochondrial dysfunction leads directly to heart failure and directly because of high omega-6, and it'll do it in 3 weeks in rats. Okay, next, apoptosis, necrosis, cell death, and this leads to diseases like macular degeneration, Alzheimer's, Parkinson's. Up on your upper left, this catastrophic lipid peroxidation cascade leads to toxic aldehydes. And I'm going to hit this right away next, and you're going to see this. Okay, so here's what happens. Most of this linoleic acid, when it peroxidizes, and then these rapidly degenerate into all of these things: 4-hydroxynonenal, malondialdehyde, oxidized linoleic acid metabolites with like 9 and 13-hode, acrolein, carboxyethylpyrrole. Here's what these do collectively: cytotoxic, genotoxic, mutagenic, carcinogenic, atherogenic, thrombogenic, and obesogenic. And just in case you're not aware, atherogenic means inducing atherosclerosis, and thrombogenic means inducing clots. You know, that right there can be a cause for strokes. Okay, so that leads to all the diseases of civilization. So we're going to look at 3 studies, I believe it is. This is a study with isocaloric diets, okay? All the same calories. 3 groups of rats for 3 weeks. Identical amounts of calories, protein, fat, and carbs, and omega-3 fats. Only one single variable in this study, and this is a very well designed study, I believe. Omega-6, only variable. 3 groups: beef tallow, olive oil, and safflower oil group. And you can see the omega-6 going from 4.4 to 7.7 to the safflower oil group is the really high 36.6% omega-6. All right, here you can see the beef, olive, and safflower, all the calories the same. It's a high-fat diet at 59%. Here's the omega-6. I've circled the interesting part, 4.4% in the beef fat group versus 36.6% in the safflower oil group. Look how high their body fat went in the safflower oil group in 3 weeks to 54.5%. So what is this? Now, make a point of this. This 4.4% is too high, and I'll show you why. Because they added linseed oil is what they really did. But here's what happened to these rats in 3 weeks. Now, they all gained weight, but relative to the beef fat group, the olive oil group gained 9.6% more weight, which is 14.8 pounds human equivalent. The safflower oil group gained 15.6%, or 24 pounds human equivalent more. Right? How's this possible? They're on the same calories. They're all consuming the same calories, right? Okay, now I had a problem with this because why did the beef fat gain weight? Here's why. Now, if you look on the far left of this, that group wasn't included, which would have been beef fat only, the one without linseed oil. They put linseed oil in here to try to give them omega-3. Well, they didn't need to do that with beef fat. It already has it. So we don't know. That group would have been 1.4% linoleic acid, but we don't know what that would have happened there. The group that's next in the blue, the beef fat plus the linseed oil, that's 4.4% omega-6, and look how much weight they gained, 27.6% more than where they were initially. The olive oil group was 7.7% omega-6, and they gained 37.2% more than what they weighed initially. And then look at the safflower oil group gained 43.2% more than their initial weight. That is 66.5 pounds human equivalent for a man in 3 weeks. And the only difference is the omega-6. They all consume the same calories. Okay, here's a study about heart failure. It's very simple, just 2 groups. A high PUFA group that got normal lab chow with 20% sunflower oil. That's less omega-6 than what Americans are consuming today on average. Then there's a low PUFA group that got normal lab chow. 4 weeks, this study. Look what happens. In 4 weeks, the group that got the sunflower oil, they have 32% reduction in their cardiac output at high afterloads, which means they're at systolic blood pressure, which is like 138. In 4 weeks of feeding, these rats have heart failure. Okay, one more. Here's an isocaloric 40% fat diet. Chow versus 4% soy oil versus 19% soy oil. Okay, this was a 32-week study, basically 7.5 months. Now they have on the far left, you can see that was the chow, the standard chow, which is 1.2% in the red. At the bottom is the linoleic acid, the omega-6 linoleic acid, 1.2%. The next group is the 4% soy oil, which is 2.2% linoleic acid. And the third group is 19% soy oil, and that's omega-6 10% linoleic acid, okay? 0% sugar. What they used good carbs in here. They used maltodextrin and starch. So no sugar. Good clean study. And so here's what you can see the weight that they gained. All right, but let me just get to the point. The mice on the 19% soybean oil weighed 55% more than mice on chow. Okay, this was in 32 weeks. Now, let me give you the human equivalent. This is the human equivalent of a 190-pound man, which I just used my weight, versus, for the chow part, versus the 19% soy oil, 10% linoleic acid, which is less than Americans are consuming today. That would have been the equivalent of a 294-pound man in 7.5 months of eating this way. They're eating the same calories, the 4% and the 19% soy oil, the exact same calories. Okay, now this is the same study. I didn't include all the categories because it's so confusing to do quickly. But here's the glucose tolerance test that shows that the soybean oil diet rapidly induces diabetes. That's the top one there. You can see that after an intraperitoneal glucose challenge, look at their glycemia. They're diabetic. And then the next one down is soybean oil plus 25% fructose. They're also diabetic. But the green line is also 40% fat, which was made up of 36% coconut oil and 4% soybean oil and 25% fructose. That did not cause diabetes. And then here is an insulin tolerance test. And you can see the very top one is the 19% soybean oil diet, which induced marked insulin resistance, even worse than the 19% soybean oil plus 25% fructose. Incredibly, the 25% fructose was protective in some way. I don't know how that works, but it was. And then they did a 25% high fat diet, again 40% fat and 25% fructose, did not induce diabetes or insulin resistance. Okay, how about their liver? You can see the standard chow in the upper left healthy liver. And then in B, upper right, that's 36% coconut oil plus just 4% soybean oil. They're getting fatty liver disease. Then go to the one below that in F, right lower, 19% soybean oil for 16 weeks, fatty liver disease. And then on your lower left, soybean oil for 32 weeks. Now they've got fatty liver and hepatic balloon entry. This is really sick liver disease. Okay, what about vegetable oil and cancer? The 19% soybean oil diet, which 10% LA, less than Americans are consuming now, in 32 weeks, caused 31 cancer-associated genes to be dysregulated, 5 cancer-promoting genes upregulated, 6 cancer-inhibiting genes suppressed. And here's the finale here. 32 weeks on a 19% soybean oil, 10% linoleic acid diet did this. Obesity, visceral obesity, insulin resistance, glucose intolerance, diabetes, frank diabetes, non-alcoholic fatty liver disease with balloon entry, 31 cancer genes dysregulated, and incredibly, the 19% soybean oil diet was worse than 19% soybean oil and 25% fructose. So this is what I want to say. Really? These oils are these fats are the same? Are you kidding me? I mean, the fats coming out of these this is a real vegetable oil refinery. This is what I can't tell them apart from petroleum oil refineries. You know, they look the same. This is what I would say. This is toxic waste coming out of vegetable oil refineries. This is extraordinarily dangerous to us. And the other one is, you know, the animal fat's divinely healthy. So I would submit to you that this is how I would propose the contribution of processed foods to obesity and chronic disease. I would submit to you 80% of it is driven by vegetable oils and trans fats, and they run together because the trans fats are in the oils. Sugar, I would say, is about 15%, and refined wheat the other 5%. All right. So how can we consume only about 1% omega-6 polyunsaturated fat? And you already know the answer, right? No seed oils. None. No vegetable oils. None of these kind of oils. No processed foods, because they're in all the processed foods. And, you know, no fast foods. Restaurants almost all cook in soybean oil and canola oil, and they are disastrous.